Welcome back to my channel Kuluru Vineeth. So today I'll continue the arrays playlist. So today's question is rotating a given matrix by 90 degrees. Okay, so what is this question is all about? So let's take an example here. So we are given an input matrix of here the given example is 1 2 3 4 5 6 7 8 9, okay, of size 3 cross 3, and their output should be, we should rotate this given matrix by 90 degrees. So after rotating this matrix by 90 degrees, this is how the output should be, like see 7 4 1 8 5 2 9 6 3. Okay, fine, the question is clear right now. So now coming down to the intuitional approach, how this can be achieved is, looking at this example, what I'm thinking is, take an extra extra matrix and put the rows of the given matrix into the column of the new matrix I'm taking. For example, here first row I'll put this as the last column elements in the new matrix, and the second row elements into the second column, and the third row into the first column. Okay, then once I copy all these elements into new matrix, and then again I'll put back all the new matrix elements into the virtual matrix, and that would give us the desired result. Okay, so let me code down that approach. That is approach 1, using extra matrix. Okay, and so let me name this as the approach 1, and here let's name the parameter as matrix and array of int array. Okay, and then we will just print out here itself, and now I will take the first, I'll calculate the size of the matrix, that is, and then I will take new matrix, that is array of size n, and I would initialize the columns as well, like this. Okay, so this will be a new matrix of size n cross n. Okay, and then I will put two loops to first get the elements of row into putting first row of the given matrix to the last column of the new matrix, and so on. Okay, so first I'll do that here. This is new matrix of j to n minus I minus 1 equals to the matrix of 1 comma j. Okay, so once we have put down that, we will write one more array, loops, and then put back the new matrix elements back to the original matrix, which would give us the desired result. Okay, so I will fine, then finally we can write a loops to print it out so that we can see the output. Okay, there is print matrix of I comma j, and let me give a space, and also print new line. Okay, so this is the approach 1, where we first put first row elements into the last column of the new matrix, and second row into the second column of the matrix, and last row into the first column of the matrix, and then put back those elements into the original matrix, so which would give us the desired result. So this is the approach 1. Now talking about the time and space complexity, since we are looping using 2 for loops, so it will be order of n square time complexity, and the space complexity I'm using the extra matrix, so that is of size order of n cross n, so it will be of again order of n square. So let me write down that time complexity is order of n square, and space complexity is order of n square. Okay, so this was our first approach. Well, now is there any other approach that we could think of to boil down the time or space complexity? Well, yeah, there is an in place transformation that we can achieve which would result into the order of one space complexity. So let me write down that approach and explain while I'm writing down. Okay, fine. So let me name this as approach to, okay, I'll write this name here, and function name is approach to, and input remains the same, and here again I will calculate the size of the given matrix, and we will put a loop to for loop to traverse the given matrix. Okay, this one. Okay, now no, this we will actually, this is different, so I will traverse till the half of the size of the given matrix only. So I'll explain how this works. And this one also from I until n minus I minus 1. Okay, and now here lot of swapping will happen. So here basically we swap the edge locations of the given matrix. Okay, so I think let me write down, then I will explain what is this. First let's take one temporary variable and store the current element we are at, and then I will replace the current element with this n minus j minus 1, this one. So okay, and now this one matrix of n minus j minus 1, this one I will swap with the matrix of n minus j minus 1 to n minus j minus 1. Okay, so this has to be high. Okay, there is some, okay, this has to be high. Okay, so again I should replace the above n minus I minus 1 with n minus j minus 1 with the matrix of j n minus I minus 1, and finally j n minus I minus 1 with the temp we have stored. Okay, so yeah, so basically this one we I will print this out so that it will be clear while or else I'll write down here how does, assuming I will write this how we, what is it that we are trying to do with this swappings. So ours is, so this is our given input, right? So first after this first round of the inner loop, so the resulting matrix how it would be is, you see here corner elements 1 3 7 9. So after first first inner loop count, what will be the output is, we move 1 to the right end, that is in place of 3, first in place of 7 in place of 1 7 will be replaced like this, and in place of 3 1 would be there. Okay, and here 4 will be same and 5 will be same, 6 also will be same, and here in place of 7 9 will come and 8 will remain same, and in place of 9 3 will come. So as you see, we are moving the edge elements by like kind of spiral traversal. Okay, so we are moving 7 to the top in one position, and 1 to the right to the 3 place, and 3 to the down 9th place, and again in the next traversal what will happen is this 4 2 6 8 is there, right? So those spiral swapping will happen. So after one more traversal, here what we get is in place of 2 we will be having a 4, and 1 will be 1 will remain same. So let me move this. Okay, and in place of 4 8 will come and 5 will be same, and in place of 6 2 will be there, and 9 will remain same, and in place of 8 6 will be replaced, 8 will be replaced by 6, and then 3 will remain same. So that is exactly what we needed, rotating the matrix by 90 degrees. Okay, so this is what the so to get at each traversal to spirally swap the elements, this is how we are supposed to write. Okay, fine, and I will write the two loops to just print the above matrix transform. Okay, so I will write matrix of I of j and give some space. Okay, and then print ln. Fine. Now talking about the time and space complexity, this I will write it as kind of spiral traversal and swapping. Okay, fine. Now coming down to the time and space complexity, we are again it will be order of n square, and the space complexity is just 1. We are not using any extra space, so this would be order of n square, and space complexity would be order of 1. Okay, so this was our approach to, well, is there any other approach that we could achieve the same solution? Is, yeah, there is one more approach that we could get the things done. It's like nothing but the finding just swapping row and column elements, and once we get the swapped row and column elements, we will again reverse the each row of the matrix, so which would give us the desired result. So okay, let me write down that approach 3. Okay, swap row and column elements, and then reverse each row. Okay, so let me name this as approach 3, and input remains the same, and again I will just keep store the size of the given matrix, and then put 2 for loops, so here what we'll do is we will just swap the row and column elements. Okay, there is matrix of I of j, and this matrix of I of j would be swapped like this, and this one will be done. Okay, so once we have done swapping, we will again traverse till size of the array, and then what we'll do is we will reverse each row. Okay, so that is reverse each row, and finally we'll have the desired result, and we'll print that matrix. Okay, that is in matrix dot indices j in matrix of dot indices, and then print matrix of I of j, and then do this one. Okay, now talking about the time and space complexity, I would say time is again order of n square. Okay, and the space complexity is order of 1. We're not using any extra space. Okay, fine. So these are all the three approaches to rotate the given matrix by 90 degrees. Now let's write a main function and execute each of them and see the output of each approach. Okay, that is function main. So let me create an object of above class, that is rotate matrix by 90, and then I will just print it as approach 1. Okay, and then what we'll just call that so that it will print. So that is rotate matrix approach 1. So this would be array of int array of 1, 2, 3, int array of 4, 5, 6, int array of 7, 8, 9. Okay, so I'll do the same for approach 2 and approach 3. Here I'll just change the name, approach 2, here again to approach 2, approach 3, here approach 3. Okay, and also let's execute and see what the output will look like. Okay, so let me print line. Fine, and let's see what the output is now. Yeah, so as we see, the given input matrix was the 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have rotated this by 90 degrees. Wait a second, approach 1, approach 2 is correct, but coming down to the approach 3, we missed something. What is it? Did I miss something? Yeah, I know where I missed. So here swapping was wrong. This has to be till I. Okay, I think now it should be correct. Yeah, you will see I missed the inner loop count here. That is, it has to be till I. Okay, so or else we'll have the same matrix as the original matrix if we just looped like I did before. Okay, yeah, so this is it for this video. Thank you so much for your love and support. Keep watching my channel. There'll be a lot more exciting content coming up your way. Thank you.